Hi everyone, my name is Rebecca Flicher, and for this assignment I was given number 6 from section 1.2. So the problem says to find the function y equals f of x satisfying the given differential equation and prescribed initial condition. So we're trying to find here a particular solution. We were given dy dx equals x times the square root of x squared plus 9 with the initial condition of y of -4 equals 0. So the first thing we want to do is find a general solution. So the way to do that is we have to take the integral of our derivative, because the only way to get rid of a derivative is to take the integral. So all we'll be left with is the y of x. So you take the integral of both sides here, and that's why it's highlighted in blue. And then what you're given at the end is y of x equals the integral of x times the square root of x squared plus 9 dx. So the way I solved it was by using u substitution. So my u was x squared plus 9, and my du ended up being 2x because that is the derivative of u. That's how you find du. Now the problem is 2x is not in my equation, so I had to get that 2 away from the x dx so that way the du is a true statement. So what you have to do is divide both sides by 2, so that way you get x dx equals 1/2 du. Now you're ready to plug in your u and du into the integral. So you end up getting the integral of the square root of u times 1/2 du. So then what you can do is, because 1/2 is a constant, you can end up taking that out ahead of time. So it ends up being 1/2 times the integral of the square root of u du. Now the next thing to do is actually solve for the integral. So as we learned earlier in our notes and from classes before, that the square root of u equals the same thing as u to the 1/2. So it makes it easier when solving antiderivatives to know how that works because of how you add the powers plus 1. So what you have here is 1/2 times u to the 1/2 plus 1 over 1/2 plus 1. So now what you're going to do is, I simplified it a little bit more, so I end up getting 1/2 times u to the 3/2 over 3/2. And then once again I simplified it more, where I had 1/2 times 2u to the 3/2 over 3 plus c, because that constant's going to be really important for the next part. So then once you cancel out the 2's here, you end up getting a simplified solution where y of x equals u to the 3/2 over 3 plus c. So what you want to do is plug back your u back into the equation. So if you remember from up here, our u equaled x squared plus 9. So you just plug it back in to where the u was, and you end up getting y of x equals the quantity x squared plus 9 to the 3/2 divided by 3 plus c. This is our general formula. So now what we want to do is find our particular solution. So we were given y of -4 equals 0. Now if you look at that, the -4 is our x and the 0 is what our y value is. So we're pretty much given a point which we can actually plug in. So what I like doing is I like writing out what we're going to plug it into, and then you write what you're plugging in to the equation. So you have y of -4 equals -4 squared plus 9 to the 3/2, that quantity there, divided by 3 plus c. So when you put that into your calculator, when you solve that, you end up getting 125 over 3 plus c. So what you're going to do next is plug your y value in. So you have y equals 0. So you have 0 equals 125 over 3 plus c, which then you subtract the 125 from both sides, and you end up getting c equals -125 over 3. So our function is now going to be y of x equals the quantity x squared plus 9 to the 3/2 divided by 3 minus 125 over 3, which you can then take the 1/3 out because it's in both parts of our function. So you end up getting y of x equals 1/3 times x squared plus 9 quantity to the 3/2 minus 125. And there you go. That's our answer.